Okay, so I will start my presentation with a short story. So when you imagine you want to buy a car, let's say today we want to buy an electric car, then you will start comparing features. We will start comparing the battery capacity. We will look for the range of the car. Since it's a fan factor, we will look really deep on the acceleration. And if you're looking for a family car, you will even check the trunk volume. You will maybe have a look at the brand reputation, for sure on the price. So these are all things you will look on. However, it's really unlikely that you will start counting the airbags in the system and the other safety measures of the car. And this is because you implicitly assume that the car is safe and will protect you. And the same is the case actually with communication technologies. We typically compare the max bit rate, the payload size, the maximum, for example, in CANxL 2048 bytes. We will take a look at what topologies can be supported, how many nodes can I connect, what is the price, are there different transceivers, and so on. It's really unlikely that somebody will start comparing the error detection mechanisms of two systems. Maybe somebody does, but usually people don't do that. Because we implicitly assume that error detection is present and will work properly and will protect us from receiving erroneous frames, right? Nevertheless, sometimes we need to talk about the topic, and this will be today. And I will show in my presentation today what effort we've made in the standardization or during the specification of CANxL at Canon Automation to bring a really good error detection into the CANxL protocol. Now, let's get into the car and let's see what happens on a bus. So a deeper motivation follows now. Now let's take the laser pointer. Okay, so when we take a look on the wires, like done in the presentations already before, then we see a waveform, right? And this waveform may be disturbed. And the disturbance may be an electromagnetic radiation, because a car or the environment where the car drives may be a harsh environment, maybe not always, but sometimes. And this disturbance modifies now our waveform. This means that the physical coding sublayer in the receiving node that converts, this is the piece of logic that converts the waveform into individual bits, so it samples the data. And this PCS sublayer will then convert the bus signal into an erroneous bit sequence. You see it's marked here with a red bit flip, bit error. So due to disturbance, we will see a bit flip here. And now this bit stream is handed over to the medium access control. And now we expect from the medium access control that he detects the error, because this is his job. He has measures to do that. And detecting errors gets more and more important because we build more and more safer systems. We head towards autonomous driving vehicles, and therefore safety is very important. And therefore we expect from the Mac that it really detects nearly all errors. There's always some residual error rate, but we want a good job from this Mac layer. And when we build now a robust and reliable system, we need two pillars, otherwise it will not work. The one pillar is the error detection itself, and the other pillar, the error handling. So you need to detect an error, and then you need to react on that error. You need always both. And as you may know, the error handling in CANxL, there are two flavors of it. So we can have the error signaling enabled, then the error handling works with error frames. It's identical to CAND, but we can also have error signaling disabled. Then we do something different. But however, this is not the topic of today's presentation. Today, we will have a look exclusively on the error detection. And error detection in CANxL means we have three mechanisms to detect errors. These are three completely different mechanisms. The one mechanism is format checks. That means we check the format. The second one is CRC checks, so cyclic redundancy checks. This means this is some mathematical stuff. And finally, we have the bit monitoring. And bit monitoring means the sending node checks his own bits if they appear on the bus. However, bit monitoring is only present if we have the error signaling enabled. And now, since you know the expressions and the topic, I will now head on to the agenda. So first, what we will look at will be the error types. So what is our threat? And these are the error types. We will look at it and we will just learn what types of errors are out there in literature and described. Then second, I will present the error detection capabilities we have built in CanExcel. And this will be the CRC concept. And then I will also show a delta view between CanFD and CanExcel, and will show how we improved the good error detection of CanFD to an even better one in CanExcel. And finally, I will show some evaluation, because the best error detection is worth nothing when you do not evaluate it, because you need to be sure that it works. It's not just a feeling, we need to really know that it works. Okay, then let's start with the error types.